All right, good day everyone, and welcome to another episode. So today we have a question. It's actually a Gcse question, and I just felt we should just look at it. It's a mechanics question from Gcse. So the question goes: a tractor and its driver has a combined mass of n kilogram. A tractor is towing a trailer of mass 4m kilograms in a straight line along a horizontal road. The tractor and the trailer are connected by a horizontal toolbar modeled as a light rigid rod, driving force of 11,080 Newton and a total resistance of 160 Newton act on the tractor. But for the trailer, its resistance of 600 Newton acts on the trailer. The tractor and the trailer has an acceleration of both 0.8 meters per second squared, and we have to find the value for m. So in order to approach a question like this, it's going to be very proper. It's going to be proper for us to quickly just draw a diagram to just show exactly how to analyze such a question. So let me just, I'm not going to draw a real trailer. I'll just write out what it's representing. So a trailer and a tractor and a driver have a combined mass of that. A tractor is towing a trailer. So it means that the tractor is actually at the front. Then the tractor is actually more like pulling a trailer. That's what I mean by the tractor is towing a trailer. So if the tractor is actually pulling this trailer, like it's pulling it forward, so to speak, it means that a tractor has a particular force, right, in which it's applying in order to move the trailer, right? So this tractor here has a particular forward force, right, that is pulling the tractor, and that particular forward force, they've given us the value of that force to be 11,080 newtons. And that's actually what you're seeing here, right? So now they said, and a total resistance of 160. So the tractor too has a resistive force of 160, because a resistive force or a resistance force is actually a force that goes against motion, right? So that is acting against the forward force by the tractor, and that value of the resistive force is actually 160. Right. So now the trailer itself also has a resistive force for the trailer, and that resistive force, let me call that FR, is actually 600 Newton. That's for the trailer. But because the trailer is being pulled by the tractor, and definitely there's a particular light rigid and rod that is towing the trailer, so the forward force that is acting on this trailer is actually the tension that's acting with respect to this stretched rod here, that's actually pulling the trailer with respect to the tractor at the front. So what we'll try to do here is that we'll try to analyze the two of them based on two different systems. We have the tractor, we have the trailer, right? So if I'm going to consider the tractor first as a system, the force F, that's the force F acting on the tractor, that force F has to be greater than the two other forces acting in the opposite direction. And the other two forces we acting in the opposite direction, we have R being the resistant force by the tractor, and we also have the tension that's acting in that rod connecting the trailer and the tractor, right? Remember that the force is a force pulling, that the tractor is using to pull the object forward. So the tension in the rod must act against it, because the tractor is using the rope, right, in order to pull the trailer in front. So the tension is acting against, that's backward for the tractor now. The resistance force acting backwards, but the force that the tractor is using is acting forward. That's the force that's pulling trailer forward by the tractor. So what we have here is that because we know that the force is acting forward, is going to be positive. That's why you can see a positive sign here. I didn't put anything indicating it's positive. Then you have a negative sign for the resistance force and the tension, because they are all both acting to the left in the opposite direction. So that's why you have a negative value here. Now, so what I'm going to do is, what's my resistant force? My resistant force actually has a value of ma. That's mass times acceleration. So I'm going to have something like F minus R minus T equals ma by opening a bracket with a negative sign here. So I'm going to make T the subject. And if I make T the subject, I'm going to have T equals F minus R minus ma. So what I just did was to take T to this other side, then bring in ma to meet F minus R here. So that if I fix in the values now, my F is going to be 11,080. My resistance force for the tractor is 160 minus the acceleration is 0.8. So I have 0.8 m, which is the mass that we're looking for. I'm going to call this equation 1. That's for the tractor now. Analyze for the tractor. So now we're going to take the trailer also as a system, and we do an analysis on the trailer too as a system. So for the trailer, there are basically just two forces acting. We have the tension in the rod that's actually pulling the trailer forward, which is actually acting forward, that's to the right. And we have the resistant force from the trailer that is acting to the left, which is opposite to the forward tension force. So that one, the tension has to be greater than the resistant force because of the fact that the object is moving forward. So that's how forces work. So the direction in which the force is traveling or the object is traveling has a greater force. So the tension has to be greater than the force, the resistant force. So if I introduce or resolve them, I'll get a resultant force to be T minus Fr. T being the force acting in the positive direction and Fr acting in the negative direction. So at the end of the day, I'm going to be having making, let's say, T minus Fr is 600 as a resistant force for the trailer equals Ma. So that my tension, making tension a subject, will be Ma plus 600. Now remember that it already gave us the mass of the tension of the trailer, of the tractor, to be 4m kilograms. So it means that the mass here is going to be 4m times the acceleration is 0.8 given to us plus 600. So that we're going to be having our tension to be 3.2m plus 600. So I'm going to call this equation 2. Right, so the next thing I'm going to probably do now is, I have tension in equation 1. I have tension in equation 2, which is actually the same tension for the two sides. Right, so what I'm going to do now is I'm going to equate equation 1 and 2. So equating 1 and 2, we have 3.2m plus 600 is actually equal to 11,080 minus 160 minus 0.8m. So we collect like terms now. The m's come together. So I have 3.2m plus 0.8m and equals 11,080 minus 160 minus 600. And 3.2 plus that will give me 4m equals, should give me 10,320. So the mass now becomes 10,320 divided by 4. 10,320 divided by 4, I have the mass to be 2,580 kilograms. So that will be the mass of the tractor and its driver combined. right? So now, this is just the analysis basically, but you can actually be asked to get attention, right? The tension that is acting that light rigid rod that was actually connecting the tractor and the trailer. So we can use any of the two equations, whether equation 1 or 2, to get the value for the tension. But I think I would like to use equation 2. So I can just say from 2 that the tension will be 3.2 times M, which is 2,580 plus 600. And if I do that on my calculator, I'm going to be having a value of 8,856 newtons. Newtons because the tension is actually a force. So basically, this is just the analysis of the whole thing, breaking down the question into two different components, or let me just say two different systems. The tractor being a system and the trailer also being a system, and analyzing them differently and bringing them together because of the fact that they are connected with a particular tension force. That's the force that acts between that rod that is actually pulling the trailer with respect to the tractor, right? So the analysis was done, and you can see how it was analyzed such that getting the resultant forces, the tractor, for the resultant forces, those that were acting in the positive direction, we're acting in the positive direction. Those are acting in negative direction, we're acting in negative direction, right? Just like your left, right, and left forces. So all of these were neatly analyzed, and if you have any issues with anything, just let me know in the comment section. And if you want any other video to be done on any concept, let me know. So this is just a part of math that's called the mechanics part of math, that deals with different forces, or they call them connected particles, that are combined together. So I leave you with this. You can go back to the video again and check out the solution, check out the analysis, and try and see if you can figure it out. And if you're having any issues, just let me know in the comment section. And hoping that more content and useful content like this will be brought to us as we go along. Thank you very much for your time. God bless you.